Alright, so we're going to try something a little different. I'll explain it more at the end. I can solve multi-step inequalities, multi-step inequalities, more than one step. You may have to combine like terms. So you have something like that, 2x plus 3x is greater than 7. Obviously, you're going to add those two together, and it's going to become 5x is greater than 7, and you would solve from there. You may have to use the distributive property. So if you have something like 2 times x plus 3 is less than or equal to 4, you're going to want to go ahead and distribute that, and it's going to make it 2x plus 6 is less than or equal to 4, and then you would solve from there. You may have to use multiple operations. Remember to do inverse operations in a reverse order. So for example, if I was going to continue this, remember that I would have to subtract 6 from both sides, which would give me 2x is less than or equal to negative 2. So 4 minus 6 is negative 2. And then I would divide both sides by 2. And that would give me x is less than or equal to negative 1. And then I would most likely graph after that. But you get the idea. So those are some steps that you're going to need to recall from previous lessons that will be helpful going forward. Okay, let's continue. What are the solutions of this situation here? Okay, so again, using more than one step. What are the solutions of this 9 plus 4t is greater than 21? Well, again, as I kind of just demonstrated, we're going to need to do order of operations in reverse because we need to undo what's going on here. So subtracting 9 from both sides is going to give me 4t is greater than 12. And then I'm going to divide both sides by 4, which is going to give me t is greater than 3. T is greater than 3. Check the solutions. Okay, well, I'm going to check it by graphing. Go ahead and draw my number line here. 0 is going to be over here. 1, 2, 3. No equal bar, so this is an open dot. That looks like that, so I'm going to be shading to the right. There we go. So, check the solutions. Let's pick something from over here, like, oh, I don't know, 5. 4 times 5 equals 20. 9 plus 20 is 29. 29 is greater than 21, right? Good, so we're awesome. We did that correctly. You try this one on your own, and then I will come back to you with the answers. So please push the pause button, do it on your own, and then come back and check it when you're done. Alright, so what you should have done is added 7 to both sides. That will give you negative 6a is less than or equal to 24. You divide both sides by negative 6. Don't forget, when you multiply or divide by a negative, you have to switch the sign. So now it becomes a is greater than or equal to 24 divided by negative 6 is negative 4. If I was going to graph that, negative 4 is here on the number line to the left of 0. The equal bar at the bottom means I have a closed dot. Because I flipped the sign now, it's going to the right. How do I check that to make sure? Well, here, let's take something that's on this part of the solution, like 0, for example, in this case would be a good one. Let's put 0 in here. Negative 6 times 0 is 0. 0 minus negative 7 is negative 7. Negative 7 is less than positive 17, which means I did that question correctly. Okay? Nice job. Let's move on to the next page. In a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. Adjacent means next to. You have at most 42 feet of fence. What are the possible lengths of your garden? All right, so there's a lot going on here. First of all, if I'm going to put a fence around a garden, that is called perimeter. I want to find the perimeter of the garden, basically, to know how much fence I need to put on here, right? So, what shape is this? It's a rectangle, which means my perimeter of a rectangle is 2 times the length plus 2 times the width. And if I have 42 feet of fence at most, it means I can't use more than that. I could use exactly 42, but I can't use any more, which means it's going to be less than or equal to 42. So this situation right here, the 2L plus 2W, 2L plus 2W, 2L plus, sorry for the handwriting, 2W is less than or equal to 42. Now, I have something else. I don't know if you noticed it from the picture. It's probably easier to see on your paper. It's this dimension right here. That dimension is 12 feet. Okay? They're calling it the width because they're asking for the length, possible lengths, which means they're giving me 12 feet as the width. So I'm going to go ahead and substitute the 12 in there, right? 2L plus 2 times 12 has to be less than or equal to 42. So 2 times 12 is 24. I'm going to rewrite this as 2L plus 24 less than or equal to 42. And then I would solve this by subtracting 24 from both sides, which would give me 2L is less than or equal to 18. And then divide both sides by 2, which would give me L is less than or equal to 2. So, possible length of my garden. I can go 2 feet this way and 2 feet that way in order for me to have the 12 and the 12. Obviously, I'm not going to have, as much space as they're showing me here. So, what possible lengths of my garden? I can have a 2 foot length or less, right? 2 foot length or less. So 2 feet or less. All right. Let's have you try one by yourself. Come back after you've tried it to see the solution. Again, you're trying to find the perimeter. Rectangular banner that is 18 feet long, so they gave me the length. Draw yourself a picture if you need to. I always advocate that. You have no more than 48 feet, which means you can use all 48 feet, but you can't use any more than 48 feet. So, again, your perimeter formula, 2L plus 2W, in this case would be less than or equal to 48. 18 is the length. That gets substituted in for L. 2 times 18 is 36. I would subtract 36 from both sides, which would give me 2W is less than or equal to 12. And I would divide both sides by 2, which gives me W is less than or equal to 6. So my possible widths are 6 feet or less. So any of those would do the trick. Okay, moving on to the next problem, which is a solution of, wow, is that blurry, huh? 3 times t plus 1 minus 4t is greater than or equal to negative 5. Okay, so here's where I'm going to need to use the distributive property. 3t plus 3 times 1 is 3 minus 4t is greater than or equal to negative 5. Combine like terms. 3t minus 4t is negative t plus 3 is greater than or equal to negative 5. Okay? So then I'm going to subtract 3 from both sides. That's going to give me negative t is greater than or equal to negative 8. And then I'm going to basically switch the sign of both. I'm going to make both of these positive, but it's also going to flip this comparison symbol the other way because technically I'm multiplying or dividing by a negative. So t is less than or equal to 8. So in other words, t can be less than 8, which none of these numbers are, and t can be exactly 8, which it is. So I'm going to choose answer A. Okay? Try the next one on your own. Get back to me when you have finished. So distributing gives me, don't forget there's this minus right here. So if you kind of forget that the 5 is there and had to distribute just the minus 2 on the outside, it'd be 2 times 4 is 8, but it's minus, so it's minus 8. And then 2 times 7 is 14, so it's minus 14. That can be a tricky part So just be careful with that, please. So that gives me 15 is less than or equal to 5 minus 8m minus 14. I'm then going to combine the like terms. 5 minus 14 is negative 9, and I also have a minus 8m. So this simplified becomes negative 8m minus 9, to which I'm going to add 9 to both sides. That gives me 24 over there. 15 plus 9 is 24. Is less than or equal to negative 8m. Then I'm going to divide both sides by negative 8. Remember that dividing flips my sign the other way. So dividing by negative 8, 24 divided by negative 8 gives me negative 3. So it's negative 3 is greater than or equal to m. And if I flip the whole thing around, the solution is m is less than or equal to negative 3. So again, if I flip the whole thing around, it's like looking at it in a mirror. That sign is going to go back to the way that it was originally, but remember that the variable is on the right here and now it's on the left. So the net gain of that is that the sign switches to the other side. What does it look like as a graph? There's negative 3 on the number line. Equal bar means that it's a closed dot, and this is telling me to go to the left. Less is left, so it's going that way. To be sure, let's take something like, what would be over here? Negative 4, negative 5? Okay, so negative 5 times 4 is negative 20. Plus 7 is negative 13, right? Times 2 is negative 26. 5 minus negative 26 is the same as 5 plus 26. That's 31. 15 is less than 31, which makes that statement true. If you have questions, please talk to me. Otherwise, let's move on. Problem 4. What are the solutions of this situation when you have a variable on both sides? No problem, we've done it before. My advice was to take the smaller variable and move it toward the bigger one. So in this case, I'm going to subtract the 3n from both sides. That's going to do what for me? Give me 3n minus 1 over here is greater than 8 over here. Then move the 1 to the other side, in this case by adding it. That's going to give me 3n is greater than 9. Divide both sides by 3, n is greater than 3. It says, what are the solutions? Generally speaking, what that means, it's saying without saying that it wants you to graph it on a number line, so please do that. So n is greater than 3. Here's 0, 1, 2, 3 is right there. Open dot because there's no equal bar. Greater is to the right. So I'm shading to the right. That's what that solution set looks like. Try the next one and check it with me when you're done. Alright, so we're going to add 2b to both sides because it's being subtracted over here. That gives me 5b plus 12 on the left is greater than 27 on the right. Subtract 12 from both sides. 27 minus 12 is 15. So 5b greater than 15. Divide by 5 on both sides. So b is greater than 3. The solution actually looks identical to the previous example. Open dot at 3, shaded to the right. Questions? Let me know. If not, let's move on. Problem 5. Solutions of special situations. And it actually, we are not going to have time to put this on the video because I only have about a 15-minute time limit, and we are approaching that limit. So let me know how this went. We'll do problems 5 and then the self-assessment together and see if this is a useful tool for you in terms of instruction. It goes pretty fast, but it leaves you a little bit more time for independent work. So let me know what you think. Appreciate it.